So in this talk, we're going to talk about security implications of exposed cloud services through automated capability inference. So before I start, I just want to have a quick few seconds for people to know more about ServiceNow. It's our third largest SaaS company, probably the fastest growing large SaaS company in the world. We operate our own private cloud with data centers across the globe, offer a platform of platforms for all kinds of workflows. And we maintain a marketplace with thousands of enterprise apps. Just to get a scale of this the operation, we do in ServiceNow Cloud, create tens of petabytes of backup every day, trillions of database transactions, billions of web requests and API calls. So you can pretty much see our interest lies in the entire gamut of stuff. If you're interested, feel free to talk. We'll talk about it more. Cool. So let's come back to mobile apps. They're everywhere, and their reliance on cloud services has been steadily increasing. And the reasons primarily lie around availability, scalability, and cost. As a reason, they end up having a lot of super interesting user data in them, which is why there have been a huge attraction from attackers. You can see lots of interesting stories around, and this has been going on for a few years now. And clearly this hasn't gone unnoticed by the community. There have been a number of work published around it. And the core reason what we see is reported is around residual cloud credentials. There are a lot of scenarios where you see hard-coded root credentials staying in a binary or code repository or something around that, right? So, and there are some blatant misconfiguration scenarios too. So the typical solutions that have been proposed is, okay, why not go for just regular non-root user credential and give them only the capabilities that they should need? And the question is this effective enough? And the reason I'm asking this is, if you take an example, AWS S3 as a service, it offers around 130 capabilities. If an app is using several of these services, how likely that they'll get it correct across all of these services for exactly the needs of this, right? So in this work, we do a systematic study of cloud capabilities that are exposed in mobile apps. In particular, we're trying to find answers for questions like, what capabilities do app developers grant to the cloud credentials they're using for their apps? Do they grant more than they should? And if they do, what are the security implications of these additional capabilities? In particular, if there is a non-privileged, benign-looking regular credential with a couple of more capabilities than they should, can they be an enabling factor for attackers to launch, big attacks, right? So there are a bunch of challenges around it. And the first is, clearly we don't have visibility into the cloud services themselves, right? So this leaves essentially the next best approximation is, okay, why not use the mobile apps and analyze them to approximate what kind of visibility you can expect from the cloud service. And clearly there'll be gaps there. The next one is, okay, how accurately can we really infer the fine-grained capabilities given a credential? And that is also complex because of the cloud access control models that are different across different cloud providers. And the last, whatever we end up doing, so this needs to scale to analyze sort of millions of apps that are out there. So to do anything meaningful, have to be able to automate it and do it really good. So towards this, what we create is a framework called PrivRuler. I'll let my colleague to start covering on this.
Thank you, Nanda. So to overcome the challenge, we actually presented an approach called PrivRuler to help us to identify the fine-grained capability of the cloud services and allow us to identify the exposed capabilities that can lead to real-world attacks. So this PrivRuler will take one application data set as input and then perform a series of analysis on those applications, including extracting cloud credentials from its code, and also mapping the cloud credentials to the capabilities, and then identify the capabilities needed by the applications. And once we have that, we can compare the capabilities needed by the application to the capabilities granted to the credentials, so as to identify the overprivileged application. After that, we can use a series of vulnerability patterns to identify whether the additional or extra capabilities will need to attacks to the vulnerable apps, like the apps vulnerable to serious attacks such as data pollution and data leakage attack in the cloud services. And due to time limit, we're not going to talk about every aspect of the analysis on the applications. If you're interested, please refer to our paper. So this talk will mainly extend our discussion to how do we map the cloud credentials to the capabilities. To answer this question, as we mentioned, there's a basic challenge related to the complexity of the access control policies. Like the cloud service, the application developers can configure different type of access control policies, such as access control list and also the rule-based access control on the cloud services. And in that case, it is difficult to recover the cloud service, to recover the access control policies in its original format. And in our work, we try to model the access control policies with its very basic format, like the cloud operations or cloud request that can happen on the specific cloud resources. And our basic idea is that we can take the credentials from the applications and then use the credential to generate a cloud probing request and send it to the cloud service so as to gather whether the request has been is served successfully or not. And using that information, we get to know whether the credential was granted the cloud capabilities. But one major problem here is that if the cloud probing requests are legitimate, and it is of high likelihood to cause unauthorized read and write to the cloud resources. And in our study, we developed a methodology which we call the induced transaction failure to avoid such kind of risks. And the fundamental idea here is that we can model the request, the cloud request, as a transaction that includes a series of checks that happens in the cloud service. And therefore, we can inject failures or errors to the transaction to ensure that the request will never succeed. In that case, it will not cause materialized read and write to the cloud resources. At the same time, it allows us to infer the capabilities granted to the credentials. So here is a quick example showing why could that succeed. And for the get and delete related cloud service APIs, and we found that they are often composed of a series of checks in the cloud service. For example, if we are sending a cloud notification service to one endpoint, the first step will be checking the container object, such as a topic in the notification service. And after that, they may do the authorization check, and to determine whether the the party can send the notification to the endpoint. And after that, they will determine the validity of the endpoint object, or the element object. And in that case, with this series of checks in mind, we can essentially inject failures to these checks. For example, if we inject a failure to the very late stage in the element object check, we can ensure the request will never succeed, meaning the notification will not be sent to a particular endpoint. At the same time, the request will still be able to trigger the first few checks in the transaction, including the authorization check. And therefore, by observing the error messages emitted by the cloud services, we will still be able to infer whether the capabilities are granted to the credentials or not. For example, if the cloud service is seeing the element object does not exist, that basically means the credential already passed the authorization check, right? If it returns access control, meaning the authorization just failed. So using this kind of information, we will be able to infer whether the capabilities are granted to the credentials without causing a real-world impact to the cloud services. And in our study, we introduced a different type of failures and to the other type of cloud service API so that we can identify a fine-grained capability list for the credentials we have extracted from the mobile applications. And with this approach, we were able to conduct a large-scale and empirical study of the exposed cloud capabilities. And in our work, we did a study on top of 1.3 million applications on the Google Play. And then we analyzed how the applications make use of the cloud storage service and the notification services provided by the major cloud service providers. And we found that there are over 24,000 applications that have used either cloud services. And further, we identified credentials from the majority of the applications, like almost 80% of the applications. And among those applications, we found additional extra capabilities on over 27% of those applications. And among them, we found that over 1,600 applications that are vulnerable to a set of attacks, such as spear phishing attack in the notification service, and data leakage attack, and data pollution attack in the storage service. So here's a few examples we have identified in the vulnerable application. And the left side is a home automation app. We found that this home automation app will send out notification to their users via the Amazon's SNS notification service. And unfortunately, we found that the credential for this service is not only granted the capability to receive notification, it also allows anyone to list the endpoints or list the users of the application and then send out messages to a particular user. And in that case, spear phishing attack can happen by sending crafted messages to a particular user of the application. And we also found a lot of cases like group applications that are vulnerable to an attack, which we call cross-app data leakage attack, due to the sharing of the credentials or due to the sharing of the, different credentials but under the same cloud accounts. So in the very end, I want to summarize this paper. So in our study, we proposed an automated approach that combines static app analysis and also dynamic probing of the cloud services to help us to infer the fine-grained capabilities owned by the credentials. This allows us to conduct a large-scale empirical study on the cloud capabilities and their security implications. This reviews a list of applications that are vulnerable to a set of real-world data-related attacks. And I also, in addition to the study, I also want to take the opportunity to introduce myself. So I just transitioned from industry to academia like not long before, and I'm now a member of the cybersecurity and privacy cluster at the University of Central Florida. And my team is mainly working on some research on software supply chain security, privacy compliance automation, mobile and IoT security. If you are interested in these directions, please scan the barcode, visit our website, and check out our recent updates. And in the end, I want to thank everyone for joining this talk, and I'm glad to take any questions if you have.